In chemical reactions, one or more of the reactants and products can exist in solution. A solution is a homogeneous mixture of two or more substances, so when you look at it, it looks uniform. There's one phase in a homogeneous mixture. A solution consists of the solute, which is the component of the solution that's dissolved, and the solvent, which is the component of the solution that does the dissolving. Normally the solvent is water. The concentration of a solution can vary widely, so we are going to measure concentration with molarity, designated with a capital M, and molarity is the moles of solute divided by liter of solution, and that's going to tell us the concentration of that solution. Let's look at a couple examples. First example, calculate the molarity of the solution. It contains 5.85 grams of NaCl, that's my solute, in 500 mils of solution. So molarity is moles solute, which is in this case NaCl, divided by liters of solution. So I have the mass of NaCl, so I'll start there, 5.85 grams. Has to be in moles. So I need the molar mass of NaCl. From the periodic table, 58.5 grams per mole. That will leave me moles in the numerator. And I have 500 milliliters of solution, which would be 0.5 liters of solution. So my concentration for this solution is 0.2 molar solution. Just designate with a capital M. Second problem, I want to prepare 0.5 liters of 0.25 molar Na2SO4 solution. What mass do I need? Well, molarity equals moles over liter. So if I want to solve for moles, I can do so by taking my concentration times my volume. So I'll take my concentration, 0.25, multiply by the volume. That's going to give me the moles of solute. So I have 0.125 moles of the sodium sulfate, but I want the mass of sodium sulfate, so take that number and simply need the molar mass from the periodic table for Na2SO4, and the molar mass is 142.1, and so the mass that would be required to produce 0.5 liters would be 17.8 grams of sodium sulfate. Sometimes solutions are prepared by diluting a more concentrated solution. Now when you dilute something, the number of moles of solute does not change. Now the number of moles of solute is equal to the molarity times volume. Well, since this number here doesn't change, I can simply take your initial molarity times my initial volume, set that equal to my final molarity times my final volume. So that's my dilution equation. Anytime I take a more concentrated solution and add more water. So here's a concentrated solution on the left, a dilute solution on the right. You'll notice that the number of molecules of solute doesn't change. I simply add more water to dilute something. So what is the volume of 1 molar KNO3 that you have to dilute in order to prepare 0.2 molar KNO3? Well, it's the same substance, I'm simply diluting it. So M1V1 equals M2V2. My initial concentration is 1 molar. I want to know what volume I need of that. I'm going to set that equal to my final concentration. And then my final volume is 250 mils. So the volume that I would be required of that 1 molar solution is 50 mils. Now you can leave this in milliliters. You can actually use liters here if you want to, but this is an equation where you can actually use milliliters to solve it. Mass to volume of a solution. I have 2.27 grams of zinc metal. I want to know what volume of HCl I need. Well, I'm going to start with the 2.27 grams of the zinc. I'm going to convert grams to moles just like we always do. And for zinc, the molar mass is 65.4. And then I'm going to go for moles of zinc. I'm going to go back to HCl, that's what I'm looking for. Coefficient's 2 to 1. So that means I need 0.0694 moles of HCl. And I know the concentration is 2 molar. So if I take this equation here, molarity equals moles per liter, if I want to solve for liters, it would simply be moles divided by molarity. So I'm going to take the moles, I'm going to divide by the concentration, and that will leave me with the volume that would be required. So 0.0347 liters. But I rearranged the molarity equation to solve for volume. Acid-base titrations. In a titration experiment, you have a solution that's of known concentration, which is called a standard. It's gradually added to another solution of unknown concentration until the reaction between them is complete. And if we know enough information, we can calculate the concentration of the unknown solution. So let's look at this example here. Balanced chemical equation. I know the volume and molarity of the base, NaOH, and I need to calculate the molarity of the H2SO4. I always start in a titration experiment where I have two numbers. So I'm going to start with the NaOH. Now if I have the volume and I have the concentration, I can get the moles. Go back to your molarity equation. Moles would equal molarity times liters. So I'm going to take, for NaOH, I'm going to take the 0.182 molar, multiply by the volume in liters, and that's going to give me the moles of NaOH. Then I'm going to go back to my balanced chemical equation. The 0.0044, that's for NaOH, but I want to go back to the H2SO4. So I'm going to do the molar ratio. There's 2 moles of NaOH for every 1 mole of the sulfuric acid. So that's going to require 0.002204 moles of the acid. And if I want to find the concentration, I'm going to take the moles of the acid. I'm going to divide by the volume that it took, which was 20 milliliters, 0.02 liters. And that's going to be the concentration. So you can kind of break this problem down into 3 steps. First step here, second step here, third step right here. But the concentration of that sulfuric acid, 0.1102 molar. 0.1102 moles per liter.